Hello friends, in this AV we will be solving the numericals of the third part of the first chapter of physics class 9, that is measurements and experimentation. This portion includes the numerical of simple pendulum, the numericals based on the simple pendulum. Now we may get three types of numericals from this portion. One is based on the direct formula, that is time period is equal to twice pi root over L upon G, or we might have to find out the frequency or time period of the pendulum, or we might have to compare the time period of two pendulums or length of the two pendulums. So let's start the numericals. The very first numerical says here, a simple pendulum completes 40 oscillations in 1 minute. Find its frequency and time period. Here we have been provided with number of oscillations and we have been given the time period, that is 1 minute. So we convert it into seconds, that will be 60 seconds, and then we have to find the frequency and time period. So here I have solved. This is the number of oscillations is 40, time is given as 1 minute, that is 60 seconds. So we know the formula that frequency is number of oscillations per unit time. So 40 divided by 60 is 0.66667. So we can round it off to 0.67 per second. Now the second part of the question says that we have to find the time period. So time period is nothing but 1 by frequency. So 1 divided by 0.67 gives us 1.5 seconds. Now the second question says the time period of a simple pendulum is 2 seconds. The moment we read this line, we understand that they are talking about a seconds pendulum, because seconds pendulum the time period is 2 seconds. What is its frequency? So frequency is 1 by time period. So 1 by 2, you'll get the answer. And what is the name given to such pendulum? It's seconds pendulum. Now the third question, here they have said that a seconds pendulum is taken to a place where the acceleration due to gravity falls to 1/4. Means the new gravity or new value of small g will be 1/4 of the previous g. How is the time period of the pendulum affected, if at all? Give reason. What will be its new time period? Here I am not solving this question because they have already given it in the hint. So we go to the next question. Next question is number 4. It says find the length of a seconds pendulum at a place where the acceleration due to gravity is 10 meter per second square, and we have to take the time period, the pi as equal to 3.14. Now here we can directly use the formula of time period, that is T is equal to twice pi root L upon G. So here we have to find out the length. So we will mold this equation in terms of L. So here we have written the given things. G is 10 meter per second square, pi is 3.14, and we assume that let L be the length of the string of the seconds pendulum. So we know the formula for time period, that is T is equal to twice pi root L upon G. We put the values. So T is 2, pi is 3.14, root over L we have to find out, and G is asked to be taken as 10. Now this 2 and 2 cancel out. So 3.14 going to the other side becomes 1 by 3.14 is equal to root L upon 10. So we square both sides so that we can get rid of the square root. Now after squaring both sides, we have 1 by 3.14 square is equal to L upon 10. So from here 10 going this side, so L will be equal to 10 upon 3.14 square. So after calculation the answer comes out to be 1.0142 meter. This is the required answer. Now after this we go to the next question, that is question number 5. It says compare the time periods of two pendulums of length 1 meter and 9 meter. Now this is based on the comparison. So here also we are going to use the formula for time period, but in a different manner. We have been provided the length of first and second pendulum, that is 1 meter and 9 meter. So here you can check for number 5. We assume that let T1 be the time period of pendulum of length 1 meter and let T2 be the time period of pendulum of length 9 meter. Now we know that time period and length, they are directly proportional to each other. Time period is directly proportional to square root of length. So based on this, we know that the ratios will be T1 by T2 is equal to L1 by root over L1 by L2. This you can check writing the full formula as well, that is twice by root L upon G divided by twice by root L upon G. So here if we find out the square root, 1 remains as 1, 9 square root of 9 is 3. So T1 by T2 is 1 upon 3. That is the required answer. Now question number 6 says a pendulum completes 2 oscillations in 5 seconds. What is its time period? And if G is equal to 9.8 meter per second square, we have to find its length. Now for this, we write the given things first. Number of oscillations is equal to 2. Time is equal to 5 seconds. Now we have to find the time period first. So we know the formula for time period is total time divided by number of oscillations. Time period is also equal to 1 by frequency, but here since they have not given the frequency, we will be using this formula. So total time is 5 seconds divided by number of oscillation completed in 5 seconds is 2. Divided, you get the answer. Now the second part of the question says we have to find the length. So they have given that the acceleration due to gravity to be taken as 9.8 meter per second square. Now let L be the required length. Then we know the formula. The time period is equal to twice pi root over L upon G. Now here time period we have calculated in the first part of this question, that is 2.5 is equal to 2 into value of pi is 3.14 root over L we have to find out, and the value of acceleration due to gravity is 9.8. So we bring this to the other side and it becomes 2.5 divided by 2 into 3.14 equal to root L upon 9.8. So here you can see I have multiplied these two. We got 6.28 and that is equal to root over L upon 9.8. Now after dividing this, we got this. As Icse allows you to use the calculator in exam, you can do so. If not, you can do it manually. Now this is equal to root L upon 9.8. Now to remove the root, we square both sides. So here I have written squaring both sides. We will have 0.398 square is equal to root cancels out and L by 9.8. So we have to find L. So we will take this to the other side. So square of this is 0.1584 multiplied by 9.8. So this comes out to be the effective length, or the required length will be 1.55 meter. Now we go to the next question, that is question number 7. It says the time period of two pendulums at a place are in ratio 2:1. What will be the ratio of their lengths? Now we assume that let L1 and L2 be the length of the pendulums having time period T1 and T2. Now we know that time and length, they are directly proportional. Time period is directly proportional to square root of effective length. So the ratio T1 by T2 will be equal to root over L1 by root over L2. Now we square both sides so that we can get rid of the root. So square root vanishes. We have L1 upon L2 is equal to T1 upon T2 whole thing square. we have been given the value of time period, that is 2:1. The ratio is given, not exactly the time period, but the ratio of the time periods. So instead of T1 upon T2, we write 2:1 or 2/1, square it, you get 4/1, which is the ratio for the effective length or the required length. Now the next question, question number 8, it says here, it takes 0.2 seconds for a pendulum bob to move from mean position to one end. What is the time period of the pendulum? Now, mean position to one end is one amplitude, and there are 4 amplitudes in one complete oscillations. So what we will do is, time period is equal to time taken for one oscillation, and in one oscillation we have 4 amplitudes, so 4 into 0.2, that is 0.8 seconds. And the last question for this exercise, it says, how much time does the bob of a second's pendulum take to move from one extreme ends of its oscillation to other extreme? Now the time period is 2 seconds. In 2 seconds it will complete from one mean position to the other mean position, and it will go back to the first mean position. For that much it takes 2 seconds. So for one complete end, like from moving from one extreme end to the other extreme end, it will be half the time period. So half the time period is nothing but 2 divided by 2, that is equal to 1 second. So that is all we have in this AV for you. Happy learning. God bless you all.